This is a video on the fundamental theorem of line integrals. The question states, find the value of the line integral over the curve C of f dot dr if the vector field f is defined as 2y minus 1 I plus 2x j. And this is our C, which is pretty funky, and we're not going to want to parameterize it. And because of that, let's hope that this vector field is conservative. So I first take m sub y, which is a partial derivative with respect to y of 2y minus 1, and that's equal to 2. Then I take n sub x, which is a partial derivative with respect to x of 2x, and that is also equal to 2. So since m sub y is equal to n sub x, I can say that f is a conservative vector field, which means that there is a function lowercase f such that its gradient is equal to the vector field capital F. So what that means is that the partial derivative of lowercase f with respect to x is 2y minus 1. So I can integrate dx and get that the integral of 2y minus 1 dx is equal to 2xy minus x plus some constant that may have y's. And also, the partial derivative of f with respect to y is equal to 2x. So I can integrate 2x dy and get that f of xy is also equal to 2xy plus some constant b that may have x's in it because y is the variable of integration. So I can put my terms all together and get that the potential function f is equal to 2xy minus x, and that takes care of this f and this f. There could be a constant, but I can let that constant equal 0 because I'm looking for a potential function, not all potential functions. Now I can use the fundamental theorem of line integrals that says that the line integral over a curve C of a vector field f dot dr, if the vector field f is conservative with potential function little f, is equal to f of q, where q is the final point, minus f of p, where p is the initial point. So on our curve C, the final point is right here at the origin 0, 0, and the initial point is right here at 1, 0. So this should be equal to f of 0, 0 minus f of 1, 0. So now let's plug in. If I plug in x and y are both 0 into the potential function, I get 0 minus 0, and that's 0. And if I plug in x equals 1 and y equals 0 into the potential function, I get 2 times 1 times 0, which is 0, minus 1. So the potential function at 1, 0 is negative 1. So I get 0 minus negative 1. And that, of course, is equal to 1. So I can conclude that the line integral over C of the vector field f dot dr is equal to 1. And I'm done with the problem.